Welcome, this is Dr. Stephen Herod from the Technical University of Denmark, and once again we are looking at OpenTrack railway simulation software. Today's topic is complex itineraries, and we'll take a look here and see how we can make a better plan, how we can dynamically move our trains across the network and give them some power to get around obstacles or to make some independent decisions on which track they use in the system. This video is not authorized by OpenTrack Railway Technology, but if you would like more information about OpenTrack software, please see their website at opentrack.ch. Now, why are we doing this? Well, you might see here in this little short video clip here how these trains are dynamically choosing which track they are on at this station. And it can be, when you first build an OpenTrack model, you learn the basics, you build the model, and you build a timetable, and then the trains run. But in reality, in the real world, of course, delays happen. There are unplanned blockages on the track. There are maybe some unplanned conflicts on the network. And you would like those trains to be able to move into alternate tracks at stations, or perhaps take an alternate parallel track out on the main line. And so how do you do that? Well, the way you do that in OpenTrack is by configuring some alternate itineraries in the course description for your trains. And then OpenTrack can allow the train to choose these alternate itineraries and reroute itself during its journey. So this video today is all about how we're going to do that. So we have a very basic little example model here, and let's go ahead and take a look at what the model is going to be for today's demo. So here is the model we're going to use for today. It is a 3-station model with a very basic structure, and it is only signaled in one direction. So we are only going to be demonstrating traffic in one direction on this line. And we have, starting at the left here, we have a very, very basic minimal station, just the minimum necessary for OpenTrack to initiate a train journey. And I have marked on here in this diagram, I have marked the meters of each track segment in the numbers above the track there. So we have 300, 300, 1,000, and so on. And then below it, I have noted what kind of signal I have configured in OpenTrack. And then the dotted boundary here shows what the station boundary is. And then below, finally, at the bottom, we have the speed limits that I have put into the system. So in station areas, I have set a 70 km/h speed limit. And on the open line, I have set a 100 km/h limit. So here we have the first station, which is Vest, and then some open, about 3 kilometers of open line. And then we go to the middle station, which is called Mit, and it has the same structure as Vest. And again, we have the track lengths marked in meters above each track segment, and the signal types are marked here in the station bounds. And again, it's 70 km/h. And then to the right, another 3 kilometers of open line, and then again another station of the same kind of structure and the same basic configuration that terminates. It has terminating tracks. So that's our model structure for today, and then we want to configure a very basic first starting train path. And that starting train path here consists of these 4. I've written 4, and I realize now that it is 5, actually 5 paths here, starting at the left, 1, 2, 3, 4, 5 paths that then are strung together to create an itinerary. And then finally, our timetable. This is our first basic timetable that I've already tested. This is with a train type of Swiss EMU 100 meters, and this is a train type that came with the sample data that I got from OpenTrack, so hopefully it is a standard train type that you can also experiment with to reproduce these results. And I'm running this train at a 60% performance level, and that performance level is set in the courses. When I create the course description, that is where you set that level. So let's go ahead. I'm going to start OpenTrack, and let's get going here with this software. So here's our OpenTrack software running now, and we've got our model up on the screen. And let's just quickly run the basic train. I've already configured all of that, and let me also open a train diagram so we can see how that looks. Here's our train diagram showing the results from the last time I ran the model. And let's open the simulation dialog and put that on the screen right there. And good, I think we are ready to go, and we will just quickly run this just to demonstrate that it is functioning. And there you go, very quickly it just ran one basic trip across the line, and so that is our basic profile here to start. Now let's add another train. Let's add another train to this service, a duplicate of this service, and the first question that might come to mind is how close together I can run them. And so let's very quickly run the headway calculator to generate that, and I am going to compress this for the video, so I will speed this up for the video, and then we'll figure out the results. So here we go, headway calculator. So there we go. There we go. According to headway calculator, we can run another train at 264 seconds after the first train, and to make it easy, let's round that up to a nice even 300 seconds, which is 5 minutes. So let's do that. Let's create another train here at the 5-minute mark, and the easiest way for me to do that is to select this train and press the duplicate button, and there it is. Copy of service A. That's fine, that's good enough, and let's just accept that. And yes, let's duplicate the timetable, and then let's take a look at the timetable, and I need to add 5 minutes to each of these times. So let's add 5 minutes at the departure, and let's add 5 minutes at each of these arrivals. So this is now going to be 14, and this is going to be 15, and this is going to be 22. There we go, and we'll save that. Very good. And I purposely, we'll come back to this, I purposely created this as a completely independent course and not linked to the same course. I did that intentionally, so we'll come back later and do some other things here later in the video. So here we go. So now we have two different courses, and let's run this to verify this. You can see that in the train diagram there. We're going to run it one more time. So there we go, and there they go. They run, and looks like it's okay to me. They are functioning and not conflicting with each other, no problem whatsoever. Okay, so now let's go back to that timetable and let's show everything. So here are our two trains. They're running just fine, but let's just imagine that the first train, the 8 a.m., the 8 o'clock train, does not have a 45-second dwell at that station, but something has changed, and it now has quite a significant dwell at that state. It's maybe, let's just make up a number. Let's 300. Let's try that. 300 seconds dwell. So that train is really delayed. Going to be really bad. Let's save that, and let's close that, and let's bring the train diagram to the front here again. Let's slow this down a little bit, and let's run this. Here it comes, and it's stuck, and the other train is following behind, is now delayed, and you can see that now in the train diagram. And it's going to finish. The simulation is going to, let me speed up the simulation now back to full speed, and there it is. And now you see the delay. and you see the delay, and a significant part of this delay is completely avoidable because we of course have two tracks at Mitt Station, and one might ask, why doesn't the following train pull into the second track and just make its station stop on the other platform? And the answer is, well, it sure could if somebody would tell that train to do that, because right now OpenTrack doesn't know that. OpenTrack has one path. It doesn't know anything different than to just let these trains follow this path, and so the second train has the copy of the service A, has no choice but to just wait at the red signal and wait to get by at the mid station. So what can we do about this? Well, we can in fact do something about this. So let's go to the service, to the course description here. Actually, I'm going to back up. Before I get to that, what I can do, what I want to explain is if we need to create another path through this second siding here, and we need to tell OpenTrack that that is an alternate possibility. The way we're going to do that is we want to create not a completely new itinerary, but we just want to create a partial itinerary, just a short itinerary that just covers the area of the diversion. And let me open up the itineraries dialog here, and then I got to squeeze that down to fit in the screen here. We're a little tight for space here. I'm going to check the box to show itinerary, and I've already done this earlier. So I have defined this new itinerary for the second track at MIT, and you can see it here. You can see where now it is lit up. So this new itinerary is only for the diversion, only for the alternate part of the path. An important tip here on doing this is your primary itinerary for the train needs to cover the entire journey from start to finish. And then any diversions that you want need to start on the original itinerary somewhere, and they need to end on the original itinerary somewhere again, so that the train can deviate from the itinerary and then get back to the itinerary in some fashion. And so so here we go. We've done this. We've got this little extra diversion here that it goes out from the main track, goes into the station, and comes back into the main track, and we're good to go. We are good to go. So I'm going to close this dialog here. So we've got that, and now if I go back to the courses, now let's open. I could do this for both trains, but it really only has meaning for the second train because the first train is never going to use this. So let's open up the following train. So here is that following train, and now I am going to check the box next to that second itinerary. You can see it now says priority 2, so it will always try to drive the primary itinerary first. It will start the train with the primary itinerary, but if something happens, what it does, if you read the manual and you follow the logic as you try the test, when it gets to this signal right before the entrance signal to MIT station, if the way ahead is blocked, it will scan this itinerary list and look for an alternative at that point. And if an alternative exists that is free, it will take it. And then it will run that alternative and then join back up with the old itinerary when it gets a chance. So we've done that. We've got that. This is good. I'm going to close this window. Let's put this back up in the front again, and let's try it. And I have a surprise coming. It is going to be almost good, but not quite. We're going to show you one more thing here, but let's just demo this and see. So here we go. We're going to run. Again, I'm going to run it at a reasonably slow speed. And here we go. So there's our first train. It's in the station stopping. It's too long, and we have some improvement, but not entirely the improvement that we might like to see. And I'm going to explain that here in a minute. Let's get the the train diagram here. So we have some improvement. We have some improvement because let me highlight these schedules here. So this is let's see, let me get the right one. Come on. There we go. No, that's not what I want. I want the line. There we go. Well, okay, close enough. There we go. So this is the first train doing its thing. It has its extraordinarily long dwell time at the platform, and then we have the second train doing its thing, and it's hard to see because it's all black and white, but you can just see the real path here, and it has its little bit of a delay because it doesn't quite get to leave. And if we look at the timetable, actually, we'll see the actual result of all this. And we're pretty close. It's a little tight in some spots, but we're pretty good here on most of the, it managed to sneak out pretty much on time. It didn't, you can see here that even though you can see here the first train has its great big delay, so it leaves a few minutes late at mid station, but the second train manages to actually not really be harmed, to not really be damaged by this. And so so that is a little bit of improvement, but that it's still not enough of an error for me to really show what I want to show you. So I'm going to go make it even worse. I'm going to make it even worse here. So let's boost this up to some really crazy number. I'm going to make this really large, 600. Let's really make this really severe. So let's try that now. Now here we go. Put the train diagram in the front again. Let's run this. And here we go. Okay, first train is stopped. Second train is stopped. But notice the second train waited for the first train to depart, which is a little odd because you look at this schedule here and you say, gee, you know, why doesn't the second train just jump over? You can see now we have a pretty severe, I'm going to stretch this train diagram out a little bit here. We have a pretty severe, let me add a little more distance to this train diagram so we can see what's going on here. And we have a pretty severe delay here and perhaps unnecessary delay. And let me try to highlight some of these lines here. There's the first train's schedule, and it's hard to see this. The actual path is this other dark line here. And then we have the second train schedule, and you see it is causing significant delay to both trains now. Let's take a look at the timetable, and yeah, you can see both trains are now both delayed. And if I make this even worse, I'm going to really go nuts on this. Let's just really make this extreme. 800 seconds, and do it again. And we'll really see an emphasis here. And we're going. And remember, the second train does not actually have any reason why it should be waiting at the platform at MIT for so long. So the question is, why doesn't the second train go in front of the first train? Well, I'm going to go back. I'm going to replay that video here. Whoops, don't want to close that. I'm going to replay that video here and show you something. Take a really good close look at it. And if I replay that video right here, notice that the first train has pulled into the station and the track in front of it is green. That means that the track in front of it has already been reserved for departure. So even though the train behind it is sitting in the second track and could leave the station ahead of the first train, because the track is already reserved for the first train, there is no ability for the dispatcher to give that permission to the second train to leave mid-station and go forward. How can we fix that? Well, there's a little trick in here. Go into the signals right here. I'm going to go into the signals here. And this little box down here, it says keep closed for station stops. So what this means is do not give permission, do not reserve the track in front of the train for that departure until it is actually time for departure. And that will have a significant impact here, and I'm going to demo that. Let's check both of them just to make it nice and clean and neat. So let's do that again. Let's run this. Now that I've made that change, I hate that when that dialog keeps opening. Let's try this again. There's the first train, but now the track in front of it has not been reserved. And look, the second train went in front of it and went forward. And I'm going to pull that video clip back here and play it for you one more time. You're going to have a little bit of an instant replay here. you can see that it plays again, it jumps in front, it gets in front of the other train. And so that is really exactly the behavior we would like to see. So that very quickly is a very basic example of how we can really improve this and have an alternate itinerary and improve the traffic on this line. So let's do something a little more advanced now. Let's go back to our courses, and so now that I've shown you how to do that, let's add the next layer to this, because we can do that at MIT, so why can't we do that at East Station over here? And the answer is, of course we can. Yes, we can. So let's do that. So let's make it at both places, and then let's make it a little interesting with a little bit of random operation. So the first thing is I am going to stop using the second train. Let's turn that off. And I'm going to edit the first train. And I have already created an alternate itinerary for the East Track 2. And this is all good. This is all, I'll save that. That's good. I'll save that. That's good. And let me just quickly show you that. So here, and the little bit of tight space here. So right there, you can see it. I've already created the, it's in red right there, the East Track, second track itinerary at East Station. And this is a bit of a software failure with OpenTrack. That, oh, there we go, that's better. That red through mid-station was just a weird artifact of the code. Sometimes these lights light up when they shouldn't be lit up. But anyway, we're back to good now. So this is the extra itinerary for East Station, and you can see it's just that little extra segment there. Now, I earlier said it had to start and end at the itinerary, and this is kind of technically ending on the itinerary because it is ending at the correct station. So it starts on the itinerary and it ends in the station of the itinerary. So this is good. This is correct structure here. And so that is all fine. So we're going to close, we're going to save that. I'm going to close that. And so now we have a new course that has the multiple itineraries for everything, and let's show everything. But we are no longer running this Service A course, so let's skip that. So here we are. This is that copy of Service A. So now let me put this back to the way it should be. This is 45 seconds. Now let's make something different here. Now to demonstrate this structure, let's add some delays to this line. So now I'm going to add some random delay. Not some, I'm actually going to add quite a lot of random delay because I want to demonstrate this. I want it to really work for this video. So we're going to put quite a large random delay in here actually. So I'm going to put in a good 4 minutes exponential. This is a 4-minute exponential delay at the station platform here. And I'm going to put that in. And now let's create some copies of this. I'd like to run this for about an hour. We already decided that we would like about a 5-minute headway under normal circumstances between these trains. So I need to make 11 more trips. I need to make 11 more trips with a 5-minute headway between them. So let's do that. And I'm going to create 11, so that will mean that I have a full hour of train operation here, plus the remainder for the trains to get into the station at the end. So for a full hour and a half of simulation then, and let's create these paths, and there we go. So now I have ignoring this one. This one's not going to run, but I have Service A and then copies of Service A at 5-minute increments. And they're going to run with a random delay of 240-second exponential, which is going to create quite a lot of delay. There's going to be quite a lot of activity here, but that's the whole point. I want to show it in the video. So now let's drive this. Let's drive this first with no delay. That is, I'm going to have no simulated delay on here. Let's zoom out a little bit and close that. So no random delay. And just to demonstrate that this can function, here we go. And there they go. They're driving, following their schedule, Nothing exciting is happening except there is some track changing going on over there. But we're pretty good, I think. Maybe it's a little too close. Still a little too tight here on the timetable, but it's pretty good, I think. Maybe I shouldn't have packed them quite so tight. Maybe 5 minutes was a little optimistic. But there's no conflicts. You see in the train diagram, there's nothing in here saying that these trains are braking or slowing for each other, so we're doing pretty good. But you do see that trains were switching tracks. And the reason they're switching tracks, even if they're relatively good on their itineraries, because that decision to switch track is made back at this signal, and so it can happen rather quickly there. So now let's simulate this with some random delay, and now we should see trains crossing over each other and jumping ahead of each other. So let's do that. I'm going to run some random delay here, run a delay scenario, and here we go. There we go. Now the first train, and the second train jumped ahead, and there are a couple of different trains jumped ahead of each other, and you can see in the string line quite a lot of activity here as well. Different paths, choosing different directions. So you can see that the trains, in some cases, if the following train is ahead of schedule or is on better schedule and the train in front is significantly delayed, we will get, and let me zoom in on the string line so we can see this. Let's zoom in on the string line a little bit here. And you can see here that train has a lot of delay, but then the train behind it jumps ahead of it. And then the next train comes, and it just fits in, and then that looks good, and then this looks good, and nothing exciting here. But then you get all the way over here, and we have another jump. Right here is a train jumping ahead of another train. Right there, it looks like. I think, try to figure out which one's which. Yeah. So you can see this activity going on, and then of course we have much better performance at the terminal station as well. The trains are able to get into the terminal station without being blocked and by other trains in front. So that is it. I hope that was useful for you, and I hope that helped you learn how to operate this feature and do something better with your OpenTrack modeling and more advanced, and brings you closer to a more realistic and dynamic model of your railway operations. So thank you for watching for visiting with me and for watching this video, and stay tuned for other videos on OpenTrack in the future from me. This is again Dr. Stephen Herod from the Technical University of Denmark, and it's been great talking to you, and we'll see each other again. Bye bye.